machine where we used to predict the spam or not spam review. Spam or not spam review. So today we will move on to the unsupervised machine learning. So you may go to the practical part of machine learning. Under the machine learning, there's one folder called unsupervised machine learning. So under this unsupervised machine learning, you have one folder called Dr. Go here. So under this, you have a 3 files. So one is email file, one is Excel file, another one is a Python file. If you have your own laptop, then you please run using your own laptop. Okay, so otherwise you can use the PC on the left here. Okay, so allow me to spend 10 minutes to explain to you what is unsupervised machine learning. So last week we have covered supervised machine learning. So the purpose for supervised machine learning is very simple. We have built this supervised machine learning. We have some input here. Okay, so this input goes through this supervised machine learning, and this supervised machine learning will classify whether this unseen data is belong to this group or this group. So these two groups are actually predefined. For example, whether it's a female, whether it's a male. So we have two different classes. So female class, male class. We want to identify whether this unseen data is belong to this female class, male class, spam email, not a spam email, and others. So for supervised machine learning, it's very simple. The idea is you just predict it and can identify what is the accuracy. Okay, so you predict something and then what is the accuracy? That's it, very simple. So what is unsupervised machine learning? Okay, so unsupervised machine learning is mainly used for clustering purpose. So this one we use for classify. So classify is not equal to clustering. Okay, classify is classified into different classes. Clustering is to find the point that having similarity, we put them together. Okay, so in unsupervised machine learning, know why or which is label during training. Okay, so it means that although in our data set we do have X features and Y, we will throw away the Y. We are not going to use the Y to train our models at all. Okay, so Y is not important. So let's say now you have this data set here. Okay, so if you apply unsupervised machine learning, this unsupervised machine learning will start to analyze the relationship between this point to this point, between this to this and this, and the relationship between each data to another. And then find which data are quite similar to each other, then we put them into one cluster. Okay, eventually we will call it as a, or maybe cluster 0, cluster 1, or cluster 2. That's it. So in this case, no Y is required. Although we have Y in our data set, but we never use that Y during our training purpose. Okay? So what is the purpose? We want to put this data into different groups. Huh? Pardon? Analyze what? Yes. Analyze. In most of the case, unsupervised machine learning is much more difficult than supervised machine learning, because supervised machine learning, you already get the classes. Then you just want to know whether your machine learning is able to classify it correctly. But for unsupervised machine learning, after we get this data, there are a lot of things that we can actually analyze. For one of the examples here, let's say now we try to collect the data from KL region, right? KL region. So we try to find out what is your income, what is your age. So this income and age, there are two features. So again, we don't use any Y here. Whether your whether it's a male, whether it's a female, whether your occupation, whatever, we don't care. We just want to take these two information, income or age, and put it here. So let's say this is the income. So this is the age. So we do a plotting here. So by using a famous algorithm, for example, the k-means, or let's say the mean shift. Okay, so this k-mean or mean shift, we're able to identify, oh, this is considered one group, this is considered one group, and this is considered one group. So what is the purpose when we do a clustering here? Okay, so after we get this data, a lot of things we can actually do. One of the things is, let's say we would like to promote the credit card. Okay, so let's say now we have three different types of credit cards here. One is called infinite credit card, it's a VIP one, where there's no limit in your swiping of card. So we have a second type of credit card, maybe just a normal credit card, it's called platinum. So there is a limit, maybe just 4,000. Okay, so if let's say we have two different credit cards here, we can identify, oh, this group of people, they are actually very young. We can come up with conclusions. We have a group 0. This group 0, they are actually very young, but with high income. Then after that, we can analyze, okay, we have another group here, group 2. Group 2, quite old, but however, they have low income. Then we have another analysis, group 1 here, old people, but high income. Group 1, old people, high income. So in this case, we just want to identify in one of the areas or one of the regions how many types of people possible. Then from there we can promote, okay, so this VIP here, we can target people from group maybe high income one, group 1 and group 2. So sorry, this one is 0 and 1, 0 and 1. So we will promote this infinite card, this group of people. Maybe we just promote the platinum card to this group of people. That is the purpose. So we try to analyze how many a group of people inside one region. Okay, so in this example here, in these practicals, there are 3 examples. Okay, so the first example is I'm going to use the syntactic data, which is not the actual data, to do a clustering. We will see how the k-mean works and also the mean shift. And second examples, I'm going to use the actual data, if possible, then I will explain. And then the third one is the application, using the image, how to use the k-means, to do an image segmentation onto one image, identify which one is the background and which one is the foreground. Okay, this one example, the first example here. So first thing first, we need to install install the necessary library. We have 3 libraries here. NumPy. Matplotlib is to plot some data, to plot a graph. NumPy is to deal with the numbers in the table form. Scikit-learn is a library that deal with the machine learning or unsupervised or machine learning or supervised or unsupervised. Then we have a second cell here, is to treat fake data, syntactic data. So in this case, I would like to treat 300 samples. It means that assume that I have this n sample 300. N features 2 means that I have only features, 2 features, features 1 and features 2. Okay, and I will ask the machine to generate 300 samples onto this space and provide this data into 3 different clusters, a very distinct 3 different clusters. So this data will somehow give you maybe somehow around here, here, and here, with the total samples of 300. Okay, so we have 3 samples here. To make blocks with a function to generate static data. So with the 300 samples, 2 features, and also 3 different clusters. So after that, you can straight away apply. So you can run this code. So and also you can look at how the data is captured on the 2D space. So this is the data generated using the Prac function. Okay, it's not a real it's not a real data, it's a synthetic data. Okay, so after that, what we can do? We can straight away apply unsupervised machine learning. Okay, unsupervised machine. One of the famous techniques is called K-means. So the K-means has only one parameter. It's called number of clusters. So these parameters is important parameters that user have to define. So we, as a user, we have to define how many clusters you want the K-means to cluster for you. You want the K-means to cluster 3, then you set 3. Okay, you want the cluster to set 5, then you set 5. In this case, I set equal to 3. So this one you can switch away to put 3 here. So you can actually put 3. So it means that you want to K-means to find out which data they are actually similar to each other and put them into 3 different clusters. So the moment that you run this code, you will get these 3 coordinates. So these 3 coordinates is referred to the center point. So if you find out, okay, let's say this is 3 clusters, and you find out what is the center point for each of the clusters. So these are the 3 coordinates. So this is the pictures 1, pictures 2, picture 1, 2, picture 1, 2. So you have a 3 mean point. Okay? So this 1, 1, 0, 2, what does it mean? It's referred to, remember, we have 3 different clusters, 0, 1, 2. So it means that the first data in your synthetic data is assigned to cluster label 1. The second data assigned to label 1. The third data assigned to cluster 0. The fourth, so you have 300 data. And so on and so forth. So now, lastly, you can plot another graph. So this graph shows that K-means has successfully identified these data. They are quite similar to each other, put them one group. This data quite close to each other, put them one group. And this data quite similar, we put them into one group. Okay? Is that clear? Okay, but the limitation for the K-means here is we have to define the value of K. So that is the main limitation. Not all the cases we know what is the value of K. So this is the limitation. Before you apply the K-means, you have to set this value first. But how to get the optimal K? So that is one of the problems, one of the challenges. Okay, so in order to tackle this problem, you can use another algorithm called mean shift. You can use another method called mean shift. The advantage of mean shift is we do not need to predefine the value of K. By using the mean shift will automatically find how many clusters inside one data space. This is the advantage of mean shift. So mean shift will automatically find which areas is having the highest density of data. In this case, by using the K-means, we have to set K equal to 3. Then we find the 3 clusters for us. Inside the mean shift, no, we don't set the value of K. The mean shift will automatically find the number of clusters for you, but we have to define the window size. Okay, the window size. This is the window. So you find which area having the highest density. So come back to the code. So we will call this function called mean shift. Okay, you can run this code. We will recycle the same data set, which are the 300 samples, 2 features, and 3 clusters. So you run this code, so we will get the same data set. Okay, so if you want to have a different samples, then you change this parameter called random tick. You can change to any numbers here. We will show you different so-called data samples. 32. It's up to you. So later on, you can modify this value here. So we have a different cluster. Alright, so after that, we can call a function called mean shift. You will see that, you will notice that if you compare with k-means, in the k-means, yeah, we set the number of clusters, right? This is one of the parameters. But in the mean shift, we didn't define the number of clusters. We define the bandwidth. So what is the bandwidth? It's the size of your window. Okay? If you don't know how to define the size of the window, as a beginner, we let the machine to find the optimal window size using this function, estimate bandwidth. So if you find the best window size for you based on the scattered data position. Okay, based on this data coordinate, you will find what is the best window size for you. So we use this estimate bandwidth. You can run this code. So you see that the mean shift is so smart, it is able to identify there are 3 different clusters in this 2D space. Okay, so you can try later on for the k-means. You try to reduce to the 2 different clusters. Then you identify there are 2 clusters. Okay, so later on, I want you to try with different clusters. Maybe you can also increase the number of samples from 300 maybe to 1000. Maybe a number of features, I think you just fix to 2 otherwise you cannot plot the graph. So this is actually only for two features. If you increase to 3 features, then you cannot see the data. You have to modify a little bit so that it shows you in a 3D space. So in this case, number of clusters may be 5. Okay, so let's plot the graph. So we have 5 different clusters. So let's see whether k-means is so smart enough to cluster this data into 5 different clusters. So we run it. Okay, yeah, so it's able to identify. So we have 5 different clusters. Although these 2 samples are quite close to each other, this k-means is able to identify there are 2 different clusters. Okay? Yeah, so I'll give you about 3 minutes, 3 to 5 minutes to go through this, the first sample. Try to modify the parameters, the number of samples, number of clusters. Try to understand how it works. The only difference between the k-means and mean shift is k-means we have to predefine the number of clusters, and most of the unsupervised machine learning we need to predefine the class, except the mean shift. Mean shift will automatically find the number of clusters for you. Okay, so you try first, then we will move on to the second stage. After that, if you want to try yourself using different algorithms, for example, this aggregative clustering, you can use it. You want to try different, for example, Gaussian mixture models, you just need to find from the Google what is the keyword, how to call the function from Gaussian mixture models, apply onto the same data set. Then also. So in this case, I use the hierarchical modeling. Yeah, so 3 clusters. Gaussian mixture model also is able to identify 2 different clusters. Okay. So to make it more precise, you have to change the value slightly. So probably you can change, you remove this whole value and change it for one value to try. So this value side, this value, actual value is a function of actually the zero side. So I will subtract this value to those quite big, that's why you will identify this one. You will find the smaller one is able to identify the five answers. The problem is, in this case, we know that K is fine. But let's say in actual case, you don't know that. In actual case, you just get the feature mark. So how do we define it? So we also try error. In this case, just find like this. There are two ways to do it. First is you have to teach the machine to be actually sure what will be the topic. Now the machine first concept. Second one is use the cluster. Okay, so which command they are using one to each other, they are using one group. Then after that you have to manually assign the topic to the
这个地方有 career fair 啊 career fair 这个拜22、23这个拜去看几点9到5想去看但是不是哎得问他在那个地方最大的这个拜不是可以对，然后这个拜四也是有天气的，有workshop，我要去嘛，那你要4点，然后没有课，然后这个上昨天我们也可以一起来哦。
哪一个？只有一个。
现在还有一个successful internship，要填 form 来着。这个。线上有，可是现在关了。这个是 webinar， 这个拜四是 workshop， 有 soft skill point， 是时候要做 soft skill point 了，没有 point。啊，9到5，这是离他。圣杰。
before then you have to imagine that very small features. Three features become 3D. Small features, higher screen are real. We put 4 on one side. So you know what is unsupervised?
Why is this one only 3 one?
This really looks like 1, 2, 3, 4, 5. Then you run, then you give 1, 2, 3, 4, 5.
Huh? Give me 1 here, 1 here, 1 here.
1, 2, 3, 4, 4.
Huh? No, 3 only, this one is a legend.
Oh, sorry, sir. Then 3 now. 1, 2, 3.
Why is this 3? They didn't even cross the center. This looks like the center cluster looks like
That's why you have to modify. You have to modify that. Okay. That's why this one we cannot control how the wings work actually. Then you find the only way that you can solve and you can make it better is you change the bandwidth size.
how do I change this?
This one you have to study in detail. The bandwidth is actually the window size. If you put a small window size, imagine you have a small window size. Okay, so this is 7 and 7
那个水机啊，那个 render stack，
then you say, oh, this is another 5. This is another 5. This is another 5. This is another 5. You have a bigger window size. So if you treat this is considered 1, 2, and 3. So the window size is very, very important. So how to define this window size? This is the limitation in definition. But we cannot control. So we.
But this one has no problem.
This one is
This one has no problem.
Hanging
This
side.
one is so no problem.
Hanging dot. Hanging is very fast. But the problem is you have to define the size. Okay. When in real case, it's impossible for us to know what is the exact calculation.
Oh, so there's no
We want the machine comfortable. You know what we know already, right? You try to go 4, or you try to go 3, try to go 3. Okay, you find that this is 1 group, 1 group. As you say just now, you have 5, right? 1, 2, 3, 4, 5. If you change the 3, then this is the result. So that's why you cannot think that, oh, now you know 5 already, that's why it's at 5. What if let's say in the actual real environment, we have a lot of scattered data, you know what is the exact number of clusters.
But the mean sheet is
Very particular.
mean sheet is unreliable. So that what other operations?
K-means, I think K-means is the famous one, it's more reliable.
Huh? That means if mean sheet is
Because the mean sheet, you never know how many clusters actually clusters first. So that's the limitation.
clearly clusters worse than the human.
Yes. This is because we have a very distinct data. Okay, let's say you have a very close one. Human cannot identify the left and go to this one I do a very obvious one. Definitely you will see that our is very good than human. But actually you have to take a actual case.
So mean sheet works better if everything is not good.
It's not very well. It is. Plot the data. Enter. Okay, sit down first. Let me explain a little bit concept about the number of clusters.
可以看。为什么在想？那我去 apply 一下。
Okay. Remember just now I said the k-mean. Okay. The main limitation for k-mean is we have to define the number of k. But in actual, we will never know what is the exact cluster. Whether you want to set 1, 2, 3, or 4, we don't know, right? So, in order to identify what is a suitable k to use, there's one technique called elbow point test. Okay, so you can use this technique to identify what is the optimal number of clusters. So this is one of the very famous techniques to identify how many clusters to define when you would like to use k-means. Okay, so what is the elbow point? This elbow point is used a technique called inertia. So what is inertia? Is the sum of square errors. Okay, what is the idea for clustering? We want a technique, a k-means or mean sheet to identify the data, they are close to each other and put them inside one group. This is considered a good clustering technique. If you have this data and your k-means or mean sheet treat this as one group of data, then you can say that this k-means is having poor performance. Because the data are quite far, they are not similar, but somehow your models put them as one group. So this is poor. This is good. Remember the ideas. Okay, we want the clustering to have this kind of result instead of this one. Okay, so what is inertia? Okay, let's say now you have a 4 students, 4 of you. You go for an internship. Okay, so you student 1 work here, student 2 work here, student 3 work here, student 4 work here. So all of you rent one house. Okay, so this, let's say this is the house, the location of the house, and this is the office. So what will be the distance between the house and also the so-called office? So you're going to add up together, right? So this is distance 1, distance 2, distance 3, distance 4. Then you add up together. So this one is actually referred to the inertia, the square error, sum of square error, the distance between the working place to your house. So let's say now, this is, let's say we have one house, which is one cluster. You assume that one house is equal to one cluster. But let's say now we increase to 2 houses. Okay, see, you have 4 students. Instead of rent one house, we rent 2 houses. So let's say this is the location of the house. So what is the total distance? D1, D2, D3, and D4. Let's say we have a 2 cluster here, 2 houses. Do you think that the total distance for the second case will be more than the first case or lesser than the first case? lesser, right? Logic, right? This definitely lesser. This D, total D must be lesser. This is the second case. Second case. I put it here. It's definitely lesser than the D1. Well, let's say we further increase the number of clusters here. Let's say now we have a human. So 3 houses, 3 clusters. So if you have a 3 cluster, that means that 2 of the students will work from home, another one still share one home. So in this case, the total distance will definitely lesser than the second case, and second case definitely lesser than the first case. So it means that your clustering is getting better and better. Better and better. Sure, in this case. Okay, but somehow if you further increase to 4, in this case, then the D will definitely become 0, which is better than 3, better than 2, and better than 1. But this is not practical. How come you can have a clustering that consists of only one data point? Each cluster consists of one data point. This is not make sense, doesn't make sense. Not a good clustering. Okay, so we can use the same technique to find what is the optimal cluster to be used in the K-mean. Okay, so what we can do here is we try to plot a graph. Okay, so this is the number of cluster. You can imagine that this is the number of houses here. So this is the inertia. Okay, so you can see that if let's say we have only one house, one cluster, so the total D here, inertia, will be very high. If we further increase the number of clusters here, so you will find that the distance is reducing. It's reducing. So how to get the optimal cluster? You have to check where is the elbow point. So what is the elbow point? Where's your elbow? Yeah. Where is this? Where is your elbow? Here. So assume that you have a graph here. So this is your hand. So where is your elbow? Somewhere around here. Then you can identify this values group 2 or group 3 as your optimal cluster used in the K-means. So this is the common technique used to define the K. If you don't know what value of K to define, you use this technique. So shown in the code here. So you will scroll down here. Scroll down, yeah. It's estimate the optimal number of clusters in K-mean clustering. So you can see that I try to find what is the initial value if I increase the number of clusters from 1 to 6. So if you run this code, it will show you, okay, the initial or the sum of square errors is getting reducing, right? Smaller and smaller. And then you try to imagine that this is the elbow, okay, this is the hand. So the elbow point is somewhere around 2 or 3. If you don't know what is the exact cluster to use, you can use either 2 or you can use either 3 in this case. Okay? So for the second case, I think you have to take your put on effort to try to understand this case too. Okay, so same process as the first case. We have a data set, but we just use the actual data case here. Then we build the machine, use the unsupervised machine learning using a K-mean 3 cluster. Okay, and then we get the result. So that's it. So this one you go through yourself. Now I want to go to the last one. For those who are using your own PC, you can I think you can run this code. But if you use the PC in the lab, I don't think you can run the code because due to the not compatibility of this OpenCV library. So the third case here is to apply the K-means to identify the foreground and the background of an image. You still remember what is the purpose for unsupervised machine learning? Do a clustering to separate different clusters. So let's say now you have one image, you have one human here. So this is the background, So we can actually apply the same technique to identify, oh, this is actually one cluster, this is actually two clusters. Then we can actually plot this human up from the images. So unfortunately, I just tried, but it showed me the error because the OpenCV library problem. For those who are using your own laptop, can you try this? Install this OpenCV first. Okay, run this code, install OpenCV, and run another code here. So by right, you will see two images. One is the original image, another one is the image that already clustered, one foreground and one background. If you use the PC in the lab, then you will see the same error. Same. How are you? Still running, okay. Wait. How are you? Are you using this? Yes. So can I show to your friend? Can put up. Okay. So so you will see that these two images, this is the original. So after you apply the K-means, then it will be obvious the background here will turn to gray. And then the foreground will turn to black. This is gray, this is black. And then you can further take it, don't worry. Okay, so we can further remove the background. Okay, this one, remove the background. Okay, this one, remove the background. And then we can crop this image up. So we know that this is actually a background, a foreground, and there's another background. Then we can crop this human out and put into another image. Yeah, this is how Photoshop works. You click, you just extract the image, right? But do you know how it works? This is how we can do. We use the unsupervised machine learning, identify the different cluster, and remove the cluster that we don't want. So this is the cluster that we want. Then we just crop out. Okay. Okay, yeah. So, and we need your help during the image processing task. You need to bring your own PC. Yeah. I don't know why the PC in the lab cannot run this library. Okay. Okay, good. So for those, yeah, you want to try this one, then you go back and try with your own PC lah. It should work. Okay, all of the yeah, I think then they are able to run this code using our laptop. Yeah, so there are many applications apply this unsupervised machine learning lah. One of it is like to segregate the images. Another one is to identify the number of clusters. Another one is to like identify the outliers or identify the abnormalities of the images. Let's say now you have a brain. Okay, we do a MRI scanner. So we have a brain here. So let's say this is the image of a brain. So if the normal brain, so we know that there are actually two clusters of images. Okay, let's say this is a brain. So this is the background, this is foreground, it's no problem. If let's say now let's say now there's one patient. So this is the patient's brain, and we have some cancer or cell here. Using this unsupervised machine learning, we can identify there are actually three clusters. Something wrong with the normal one. Normal one, we have only two clusters. But then if we scan this one, you have a three cluster, then something wrong with your brain already. Then we can actually further analyze what is inside this picture. We can further analyze what is this. Okay? Yeah. So in unsupervised machine learning, it's not just to cluster. There are a lot of things that you can do. Even in the Google search engines, documentations, you have these journals, document segmentations. We also use this Chinese method. So in your assignments, there are many things that you can do actually. So it's not only limit to cluster the data to two different cluster. That's it. There are many things that you can do. Okay. So any questions? No. You? How about you? This one you can run it because the library problem. We have to change the setting. Yeah. So you just go back up, right? Yes. You go back and run. Okay. Okay. How are you? Okay. Okay, good. If all good, then that's all for today, lah. Yes. Unable to.